Okay. Hello, everyone. We are very happy to have the opportunity to present to you our research project and how this implementing into how can you implement this inside a spacecraft. So our project is about how to implement a trained neural network into NASA cFS for space applications. So let me give you some brief overview of our presentation. This is about how in our project we are managing to work with neural network based compression images, how to implement that inside a spacecraft. I'm going to show you what our software architecture implementation, and I would like to show you a live demo to how we can do that. And at the end of the presentation, what are the next steps to do that? So I'm going to lead to Dr. Mehta to present the next couple of slides. Thank you.
Sorry, I want to say the star of the show is still Rafael. I just want to take a few moments, not taking anything away from him, to give you an overview of the project that we are working on. So I'm sure all of you know that sun is pretty much essential to life and everything that we do here on Earth and perhaps in the solar system, right? But do we all know, how many of you know that actually it can be detrimental and hazardous to us, our life, as well as the technological infrastructure? And what I'm talking about is space weather, right? There are several aspects or phenomena that sun undergoes that results in space weather or short-term changes that can be significantly hazardous to us, okay? Examples of this, because this is a flight software workshop, I'm going to kind of talk a little bit more about the space aspects of this. So I'm sure being software engineers, you heard about single event upsets, spacecraft charging, discharging, radiation exposure for astronauts, whether it be on the ISS or now that we are planning to go to Moon and Mars, that also is very relevant. And so over the last few decades, we've kind of grown our awareness of how important it is to study the sun and understand it. And so we've had different missions kind of looking at the sun from different vantage points, right? And a lot of the imaging, a lot of the study happens in the form of imaging, right, from different vantage points. And because of the distances involved in these missions, right, they are very far, L1, L5, along the Earth orbit, going around sun. Compression becomes a very critical aspect when you're trying to download the data that's collected on a spacecraft, right? So within this project, we have two components. One is to train novel compression schemes, and this is to take advantage of the spectral redundancies, the temporal redundancies. And so if you're interested in that aspect, I invite you to follow our work on this project. But this talk is mostly concentrated on how do we go about taking these novel and really challenging or other complex architectures for the algorithms and deploy them on board spacecraft, because that is, if we can develop all the algorithms we want, but if we can't deploy the developed algorithms on a spacecraft, we're really not going to go anywhere with it. So this talk is really going to focus on Rafael's work, the second component, which is talking about deploying these algorithms on spacecraft. Thank you.
Thank you, Dr. Mehta. Okay, well, so as Dr. Mehta says, we are working as well with how to implement this type of neural network inside a spacecraft and to deploy, and we can do that without dependency of what is the framework that you use to develop these neural networks, and without the dependency of the whole complete version of the framework inside the spacecraft. You need to run this inside the spacecraft without using the framework. And we need to do that in a lightweight environment as a spacecraft is. So, well, for the purpose of this demonstration, we are going to show a very simple vanilla convolutional autoencoder model. And this is one example of this. We are getting some images, solar images, and we apply this, the encoder part of the model. With this part, you are going to get a very simple piece of data that is called Layering space or Layering vector. And after that, you are going to, in the second part of the model, you can simply get this information and recover back again the same images that you have in the first beginning. So for this demonstration, we are working with the image itself, with the image files itself, but we are working for getting not really the images files, but the raw sensor data that comes from the spacecraft. Okay, so well, how can we do that? Well, we are using for now the cFS the cFS application to manage this. As you know, this is one of the best options to work with software implementation inside spacecraft. So we, in order to demonstrate this, we are only implementing the encoder part of the neural network implementation, and because the spacecraft is going to get the solar images, and you have the trained encoder part in the spacecraft. With that, you are going to get the latent vector or the compressed information, and you are able with that transfer this information to the ground station. And in the ground station, you are going to get back the original images as well. So okay, so this is our proposal. So how for example you can work with many types of frameworks to work with neural networks. You can work in a cloud environment as Google Colab. For example, we are working with TensorFlow inside Google Colab, or we are working as well, for example, with PyTorch framework inside a local environment with Miniconda as a container, with Python and Jupyter Notebook. But at the end, with both type of environments, you can you can develop, train, and get a final model to apply in any place you want. But the thing is, with these two frameworks, you can obtain a trained model as a script. With this script, you can run the same model outside those frameworks. You can run these models, I don't know, maybe in a different environment. And in our example, we are going to run these models inside a spacecraft. So let me show you, for example, this is the part of the demo. We have here our Google Drive related with our TensorFlow environment. We have here the encoder part, the decoder part, and this is our. Let me show you this. I don't know what is happening here. Okay, yeah, great. This is our model in TensorFlow. We are running here to show what are the images that we're going to process. Here we have 3 images, each one consisting of 3 wavelengths of any image of the sun, and we are going to process these images with our already trained model. This model resides in this H5 encoded H5. We're going to predict this compressed file that has the same information of images, but in a better way, in a compressed way. And this file represents the same information of the images, but we are going to run this exactly the same process, but inside the spacecraft. So this is not important to run it here, but at the end, the important thing here is we are going to get the encoder part of the model inside in a script. This script is the same that we are going to run inside the spacecraft. So this is already run it. So let me show you that in the input-output directory, right now there is the same information of the original images. Here there are 3 images with 3 wavelengths. So here's only an example. We have here 50 float numbers representing each images. So we have 3 images here, and we have the encoder model. This is the important thing. This is the encoder part of the model that we are going to run inside the spacecraft. So this model, it's made of some files that I only wanted to see what are these files. So great. Let's go to the presentation. So great. So this is our architecture to manage this. In the ground station, we are working with Cosmos application. So this is this application that you need to send commands to the spacecraft and read the telemetry from the spacecraft. And we have here the scripts that we needed to. For example, this is the script that I already show you, that I already generate. And this script is available to run and to send this to send to the spacecraft. So for example, I'm going to send this script to this implementation. And in order to do that, we need to have this script inside the Cosmos environment. So to do this, I'm going to copy these files to the okay. This is the model that I already generate. So I copy this encoder file to the Cosmos environment, and with that, this model is available to send it to the spacecraft. Okay, so okay, great. Now, in the space side of our running implementation, we have this virtual machine, Linux Ubuntu virtual machine, and we are running in there this bundle of NASA cFS. This is a standard cFS implementation. We added this cFDP component, this data storage component. You know that this component is very necessary to upload and download any file that you wanted to work in. And with that, we are going to upload our script and set it to NASA cFS. But the thing here, the main important thing here is we develop our own application. This is our contribution to NASA cFS. We developed this encoder application. And this encoder application needs to work with a standard cFS library. We developed these libraries with a standard interface with the encoder application. And this library is meant to use a C++ API to work with these models. So in that way, we can develop any type of library, for example, for PyTorch, for any other framework. And you can simply use this library to read the model. And with that, you can read the images. And the Coder app is going to manage all of this information and generates what is called the learning vector or learning space. And with CFDP, you simply send back again to the ground station the information that you get from the images. And with that, you can work with that in your own framework to get back again the images, the original images. So, well, great. So right now, I have, let me see here, advance a little more this. So this is our Cosmos implementation in my own machine. So with that, we see that we are working with some commands, and we can wait for telemetry responses. And right now, let me back again a little more. Okay, and we have here in the right side our screens for the telemetry of the spacecraft. So, for example, here we have the telemetry of the file management application, and with the telemetry we can see what is the content of any desired folder or directory inside the spacecraft. And with this telemetry, we can see what is the output, our own component, to see what is the result of the compression algorithm running in the spacecraft. So right now, this is our Cosmos implementation, and let me show you. Okay, well, and we have in the virtual machine, we have our running instance of the spacecraft. So great. Let me go to the next. So this is our implementation. This is let me show you what is the workflow, our normal workflow to run this. So the first step is to start our cFS implementation. We need to start it. We need to start the telemetry. So let me show you this. Okay, I'm going to go a little further. Okay, this is the implementation of the spacecraft. So yes, I'm going to run the telemetry in Cosmos. And with that, we start the telemetry in the system, in the cFS application. Here we can see the telemetry is already activated. Great, perfect. And Well, the first step in this demo is to send a command to CFDP application inside the spacecraft. And with this command, we're going to send our model implementation to there. So you can think of this. Oh, sorry. I don't know why is this. Okay, yeah. We can think of this. You are working, imagine you are working with a better version of your model. You have a new version, you have improvements in that model. So you need to simply upload the new version. Right now in the spacecraft, there are these files. These files represent the model itself. We already have this model in the spacecraft, but we wanted to run a newer version. So for that, I'm going to run these commands to create the folders in the spacecraft and to upload all the files needed in the spacecraft to have the newer version. So great. Perfect. Great. I created these folders. And next step is to send all the files to the spacecraft. We can see here that these are the folders of our local implementation of the model. And we can see here, this is the folders where all these files are going to reside in the spacecraft. So let's go. Let's do that. I am commanding to send these files to the spacecraft. So we can see here some of these files are already in the spacecraft. I transferred variable index, gets metadata, and I will continue to send these files. All of these files are very necessary to run your model in the spacecraft. So this is only a demonstration how you can upload files to the spacecraft using Cosmos. So let's do that. Great. So right now I'm starting with the next file, and we can see that in the file system of the spacecraft, we have now this file updated. This is a different date, so now it's updated in the file system, and we are going through the process of uploading the files. Here we are working in the last file, the previous file of the last file. Perfect. And perfect. After some minutes, because some of the files are bigger, so after some minutes, the last file is already in the spacecraft. So great. Right now, okay, this is perfect. So right now, all the files are in the spacecraft. So the next step is to show that CFDP component is already saved all the files in the data recorder or file system in the spacecraft. Perfect. So I run this command, and as you see, all the files are new. Even this is a new file in the file system, and great. Everything is fine, and all the files are in the spacecraft. Perfect. So the next step is to check if all images that we need to read in the spacecraft are already in the correct directory. So we have this, imagine any space science that get all the images from sensors coming from the sensors of the spacecraft, and this space science save this data through the data storage command. And great, let me check. Let's see if all of the images. Imagine we are getting these images and are already there in the spacecraft. So let me go through this. So as you can see, all the images are there in the spacecraft. We can see here the image 1, 2, 3, 4, and so on. And well, we are simply showing that all the images are there, actually are there in the spacecraft. So great. So the next step, this is the important thing of the demonstration, is to run our component. Our component, we are going to send a command to process the any images that you want to process. For example, 3 images, 2 images, whatever you want. And this component is going to utilize its library, the corresponding library. You can send a command to tell the encoder application if you want to work with PyTorch or TensorFlow library. So this library reads some images, reads the encoder model. With that, you are going to get back again the information, the compressed information, the layering vector that process. So the neural network is residing here in this library. So with that, you get the compressed information, and let's see how this is happening. So in order to do that, we need to tell the data storage component that we needed to send all of these packets that comes from the encoder application and send it to the data folder. So right now in this data folder, I create this data folder. There is nothing in this data folder. And in the next steps, we are sending commands to data storage to abilitate to activate this folder to receive messages from our encoder application and save it as a file, as a binary file in the spacecraft. So great, I'm going to do that. Go. So right now the data storage is activated. So the next step is to send a command to our own component that is called encoder. This is the command, en encode images. This is the type of the library that we're going to use. This is the type corresponding to TensorFlow. I'm going to process 2 images, starting with the image 1. So this is the command running. And we can see now this is the response of the encoder application. We process 2 images. And we can see now there is no more image 1 or 2 because we delete the images 1 and 2. And let me show you again the process, but with the next 4 images. This is the response of the latest image compressed information. So let me go to the next step. So great, I'm going to process 4 images, starting in the image 3, obviously the same library. I'm going to use the same library. Well, let's go. Great. Okay, in total, I am processing 6 images with 2 commands. I received new information of the last of those images. Next, I needed to delete these images, and also there is no more 1 through 6 images in the spacecraft. So I can show you here as well that we process 2 times the TensorFlow library with 2 images first and the 4 images next. Each of one of these images with 50 floats wide. Great. So the next step is, well, let me back again to our presentation. So right now, the encoder application sent those messages to data storage application, and this application saved the latest vector, the layering vector to the spacecraft. So let's see if this is true. So I simply run the check directory, and we see now there is an encoder file with all the information of these 6 files, 6 images that are already processed. Great. So everything is running correctly. So the next step is to simply send a command to CFDP to download this file that I created in the spacecraft. So let's do that. Great. This asked me for the file name that I wanted to process, and the file is starting to downlink. Great. So right now we see that in the spacecraft, this is transferring. This is correct. So we have now in our ground station the compressed information of these 6 files running our implementation of the neural network. So great. So we need to wait to the command finished. Okay, great. Everything is fine. So this is our environment, local environment. We have now the same file in our local environment of the Cosmos. So the next step is simply to send this file to our whole complete framework of TensorFlow to deconstruct or reconstruct the original sun images using the decoder part of the neural network. Great. So let me show you this. For doing that, I simply need to copy this file to our Google Colab or Google Drive related drive. Okay, so I could copy this file into input-output directory. So we can see now The file is already is there, and this is the Google Drive. So I'm going to show you how to simply run in the decoder part of the model. I am able to simply get back again the images. So here, this is the decoder part of the model. This is the file that I'm going to read, and I simply run the model, and we can see here that all the numbers that represent these images are in the ground station, and this is the original images. We can see 6 images, each one representing which one with 3 wavelengths. We can see that you can see here the shape of the tensor is 6 files, 6 images, and 50 floats per image. So, well, with that, we are demonstrated that it's possible to run any type of neural network inside spacecraft. So, great. This is the beginning of the video. Okay, great. So, for the next steps in this project, at least in the part of the implementation of the neural networks in the spacecraft, we need to integrate more advanced neural networks. This is a very simple neural network. So, we need to integrate more advanced examples using the same architecture. But we also wanted to build a complete hardware and software demonstration based in cFS or even in a different architectures. And obviously, we need to analyze metrics and data utilization to optimize the process and the resources in the spacecraft. So, well, hopefully this is good for you. Okay, thank you everyone for.
Thank you, Rafael.